Hello everyone. How are you all doing? Hello. Please let me know in the live chat if you can hear me. Hello everyone. Good morning. Hi Aniket. Good to see you. Can you hear me, or can you just let me know in the live chat if you can hear me and I can start off? Oh, awesome. Thank you. Awesome. So let's get started. Is there anything? Just give me a minute. I'll just get the links set. Here's the code. Awesome. Awesome. Hi y_p. Hi debugger. Awesome. Thanks, Ashank. Awesome. Y_p, yes, you can watch it as long as you have a knowledge of what do you say? You know what like basic DP is, but like you just need to know what subsequence. You actually don't need to know what a subsequence means either. You don't need to know a lot either. You can watch it. Yes, you can definitely watch it. You probably just need to know the basics of programming language, and that's it. You're ready to watch it. Awesome. I'll get started. So, welcome to CodeBeyond, everyone. I'm Sai Avinash, and in this lecture series, I'll be teaching you DP through this CodeForce's educational DP, Atcoder Educational DP contest, which is a really nice contest made by them, which has problems of increasing difficulty. And if you solve them, then if you solve like most of them, like 80% of them, you'll cover a variety of topics that are usually asked like in DP. Like you know your basics, and the rest is based on your problem solving skills. And I would be covering almost each one of them. I won't be covering the end harder ones, because you probably need different topics to cover them. Otherwise, yeah, that's what's going to be covered. So a little about me. I am an SRE at Google Dublin. I'm AR4 in CodeChef. I'm red and 7-star there. My max rating is International Master at CodeForces. I'm currently a master there. Previously interned at Uber. I'm also a Snackdown finalist, CodeChef Snackdown finalist. The subjects that I take are discrete maths, dynamic programming, graphs, and a lot of other competitive programming topics. Use the code SciLive to get 10% off on the Unacademy Pro subscription. So, Unacademy presents college projects. So it goes live every Friday night at 10 p.m. It's taken by Raj Vikramaditya. It's a part of Unacademy's career as a developer subscription at only $9.99 per year. So do check it out. In this, he would take a few college projects, pick up a few students, pick up a few projects in general, and he would suggest what to improve and what's missing from those projects, and so on. Now we have the CodeChef Apprentice. This is the show every Saturday afternoon at 2 p.m. It starts on 14th August, and it's taken by me. In this show, I would be picking up a student, and I would be mentoring them throughout the session, and I would discuss with them what the blockers are. And if you are a beginner to competitive programming or programming in general, chances are this is going to be really useful to you. So again, it's taken by me, and I would also be doing some live problem solving as well, clearing your doubts in general. So do check it out. So do subscribe to do join this Telegram channel, because you get live updates on this Telegram channel about what the latest classes are, so that you don't miss any. So don't forget to subscribe to join this Telegram channel. So what are you waiting for? Like, if you think you're gonna like this video series, or you can like it after you watch the video, that's perfectly fine too, if you think it's going to be useful to you. And if you think if you have a lot of friends who are at the beginning of the competitive programming journey and want to learn more about about programming in general, competitive programming in general, you can suggest them this channel, and I think it's going to be useful to them. So, and don't forget to click the bell icon. Awesome. Let's get back. Let's get to the crux of the video. Longest common subsequence. Longest common subsequence. All right. Let's check it out. One sec. So this is the longest common subsequence. So let's check the question. Let's discuss the problem statement first. You're given a string s and t. You're given two strings s and t. You need to find one longest string that is a subsequence of both s and t. That's it. That's the question. So find the longest string that is a subsequence of both s and t. So is the question clear? It's okay if you don't know what subsequence is. I'll show it to you. What's the name? Sketchpad. Yes. Again, I don't. Awesome. So what's the question here? Given two strings, find the longest common subsequence. Given two strings. Longest common subsequence. All right. Now what is, first of all, longest common subsequence? First, let's break it down. What is a subsequence? Subsequence, we can look at the definition right here. A subsequence of a string s is a string obtained by removing 0 or more characters from x and concatenating the remaining characters without changing the order. All right. So if the string is, say, Atcoder, remove 0 or more characters. You can, Atcoder is a subsequence of Atcoder, or you can remove 0 or more characters. Let's say remove T, O, and D. A, C, E, R is an Atcoder. A star is an Atcoder. Similarly, you can just remove A. T, C, O, D, E, R is an Atcoder. Similarly, an empty string is also an Atcoder. An empty string is also a subsequence of Atcoder. Why? Because you can remove all characters and there's nothing to concatenate. But by definition, it has to be a subsequence. Please do not confuse this with substring, where substring is, I'll give you an example. Substring. Every substring is a subsequence, but every subsequence is not a substring. Every subsequence might not be a substring. Sorry. Substring. For example, you have A, B, C, D, E, F. Substring is a contiguous subsequence, meaning all the characters in the substring that are present, they should be occurring continuously inside the string. If s equals to this, t equals b, c, d, z equals e, f, or x equals another a, b, c, d. All of these are substrings and all the subsequences, but more importantly, substring is a more stricter word. It's saying that all of them occur continuously, meaning B, C, D, B, C, D, E, F, E, F, A, B, C, D, A, B, C, D. All of them occur continuously. That's what makes them a substring. Whereas subsequence can be this A, D, F. You can pick anyone. You can pick characters from anywhere in the string, but their order has to remain the same. But again, D, A, F is not a subsequence because the order is not the same. A, D, F is a subsequence. A, F is a subsequence. All of these are not substrings, but all of these are subsequences and substrings. A is also subsequence, it's also a substring. A, B, C, D, E, F. This is both subsequence and the substring. Like, if you say that it's a substring, it's enough. You don't need to tell that it's a subsequence. It's understood. Is that clear? First of all, is this a definition of subsequence clear? All right. Now, what do we have here? Longest common subsequence. So what is a common subsequence? Longest common subsequence. You're giving two strings s and t. What is a common subsequence? A common subsequence is a string which is a subsequence of both s and t. Right, that's what it means, common. All right. Now, there are going to be many subsequences, and you just need to find the longest one. For example, you have A, B, C, D, E, and A, C, D, B, E. All right. This is A, by the way. This is D. Sorry for my handwriting. For example, you have A as a subsequence. A is present in both. That's also a subsequence. No one's stopping you. A, C, D, A, C, D, A, C, D is a subsequence of this string. A, C, D is a subsequence of this string as well. A, C, D is also a subsequence. Now, A, A, E. Let's check A, A, E. A, A, E. It's present in this, but it's not present in this. It's not a subsequence of this. It's a subsequence of this. So A is not a common subsequence. So now here we can see that A, C, D, E. A, C, D, E. A, C, D, E. A, C, D, E. This is also a subsequence, and if you look closely, this is going to be the longest common subsequence. This is a common subsequence, and if you look closely, it's also going to be the longest. Look carefully, it's also the longest common subsequence of these two strings. Right. Awesome. Any doubts with the question? First of all, given two strings, you just need to print the longest common subsequence. Just also note that empty string, it's a common subsequence of both. Right. So if you take any two strings, empty string is always going to be the common subsequence. All right. It might not be the longest, but it is going to be some common subsequence. Is the question clear? First of all, everyone? Any doubts with the question? If it's clear, can you please let me know it's clear? Awesome. Awesome. One second. Awesome. Now, how do we solve this? How do we solve the longest common subsequence problem quickly? All right, let me get to that. How do you solve it quickly? So we had two strings, A, B, C, D, E, A, E, C, B, D, assume. Now in the longest common subsequence, we define the state as L, R, DP, DP, L, R. All right, now what does it mean? Given two strings, S. Now, DPLR represents, okay, before that, one second. I'll explain a small topic, like not small topic, a small concept, which will lead you to getting to DPLR. Instead of directly getting to DPLR, how could you have come up with the solution? Let's look at it. Longest common subsequences of S and T, right? What does it mean? Look at the last two characters. So, E and D, right? So we can have both E and D in the subsequence, longest common subsequence, if right, but we can't have both E and D. Why? Because E is not equal to D. If we have both E and D, there should be the last characters of the subsequence. One of them should be the last characters of, if it's E and D, we know that ED cannot be, because the last character cannot be the subsequence of this, right? If it starts with E, it has to end with D. So there are two options. We have either E present or D present, right? Now if you have E present, then it's basically like one sec. Aniket is asking, naive approach would be to generate all the possible subsequences for both strings and count the max length of the common subsequence. Yes, that's correct. Aniket's correct. Naive approach would be generate all the possible subsequences. Yes, but that would be 2 power n. So we shouldn't do that. 2 power n into n or something like that. All right. So longest common subsequence S comma T. Right. What do we have here? If let's add another character here in the end called Z. Like let's say S had Z in two same characters in the end. Now if there are two same characters, we can just write 1 plus LCS of, let's say, let's define the state as L and R. LCS of, and let n equal size of S, m equal size of T. LCS of n comma m, this will represent what is the longest common subsequence of the first n characters of S and the first m characters of T. Okay, let's define this as a state. Now, this would be equal to, if the last characters are equal, then this would simply equal to 1 plus LCS of n minus 1 comma m minus 1, right? Straightforward. Otherwise, what is it going to be equal to? What is it going to be equal to? If last characters are equal. If S of m minus 1 equals T of n minus 1, then this is equal to 1 plus LCS of m minus 1 comma n minus 1, right? Else there are two options. You can either skip the nth character, you can either choose to never include the nth character or never include the nth character. Else it's equal to maximum of, if you never include the nth character, if you choose to never include the nth character, this is basically LCS of m minus 1 comma n comma LCS of n comma m minus 1. Isn't it? Isn't that the case? First, look at the y underscore p saying a dot. What does that mean? Is that clear? Is this clear what I've explained? The else part. Okay, I'll explain it. One second. All right. Awesome. So what's the else part here? What am I doing here? I'll show it to you with an example that'll be more clear. So LCS of m comma n. Say you have two characters, banana and you have another character, Atana, something like that. So since the last character is equal to in both, this is equal to basically 1 plus, this is m comma n minus 1. Sorry. Yeah, thanks Upmanu. So banana and Atana, say you have two characters, S equals this and T equals this. This is basically 1 plus, since last characters are same, you can assure that last characters are gonna be present in this subsequence, common subsequence, because you can be a bit greedy over here. If the last two characters are same, there is no reason you shouldn't include it, because if you don't include it, the answer will be at most if you include it, right? So the last is going to be same. So you have LCS of banan comma atan. Now this would again be, since the last characters are same, it's going to be 1 plus LCS of bana ata. This is going to be 1 plus LCS of ban comma 80. Now what's the LCS of ban and 80? Okay, wait. LCS of ban and 80. Ban and 80. Let me just. Now LCS of ban and 80 would simply be, you either include n in the subsequence or you include t in the subsequence. It's either LCS of maximum of, in this case you're probably going to get both the answers the same, maximum of LCS of BA comma A, BAN comma A, or LCS of BA comma 80. And again, this would be LCS of BAN comma A would be LCS of max of LCS of BA comma A comma LCS of B comma sorry BA comma A comma max of LCS of BAN comma empty string, which this would be 0, and so on. I'll give you with I'll draw the table and show it to you, and it'll become more clear then. Okay, awesome. I'll draw a table and show it to you how this works. Awesome. So let's take a good example. We have S equals A B A N C D A. T equals B A C. Oh wait, that's going to be too huge. B A N C A. T is going to be B A N D E A. All right. Now we draw this table here. B A N D. Oh wait. Up goes S. A B A N C A. Down goes B T. B A N D E A. Now we draw lines here. We draw more lines here. All right. What do we do now? Now let's fill from the top. Let's do bottom top approach, bottom up approach here. That's what we need, right? Awesome. So now every cell corresponds to the LCS of this, everything, the columns corresponding to it and rows corresponding to it. For example, this cell will correspond to the LCS of BAND and ABA. This cell will correspond to the LCS of BAND comma ABA. Similarly, this cell would correspond to the LCS of ABANCA and BAN. Similarly, our answer would be the last cell, right? Okay. Now, let's construct this slowly. What is the LCS of A comma B? It's 0. Now, LCS of AB comma B, it's basically, you either include B, since this is going to be LCS of AB comma B. Since the last character is same, this is going to be LCS of empty string. Even if one of them is going to be empty, your LCS is going to be 0. So we can write that as a boundary case. So here we have LCS equals 1. LCS of ABA comma B, again it's going to be 1 since B is a part of B. We write the boundary cases first. We will fill the first row and the first column first. We can do that brute force, right? And similarly, ABN is going to be 1, 1, 1 because B is going to be present in all the prefixes of this first one. Similarly, BA and A is going to be 1. BN and A is going to be 1. Again, 1, 1, 1 because you can't get greater than 1. Now is where the recursive part comes. LCS of BA and AB. Now, since the last characters are different, we take the maximum of this and this, meaning LCS of BA comma AB. What are we doing here? We either pick the last character from, we either don't pick the last character from this or don't pick the last character from this. It can happen that we never pick the both of them. Okay, but first we'll iterate through a smaller state which is more simpler. So say we never pick this, we never pick the last character of the first string, then it's basically LCS of B comma AB or LCS of BA comma A. Now you might ask, you can not pick both of them as well, right? You have a choice not to pick both of them as well. Yes, you do have a choice. It can happen that you don't pick both of them, but that is already covered in this. When you compute this, you're already doing, you either, in this, when you're computing, you're either doing LCS of B comma A, because you, okay, wait. In this case, you're going to pick both, because you're going to pick at least one of both, because BA and AB, at least you're going to pick B or you're going to pick A. In this case, it's not going to happen, but I'll tell you that case comes, when that case comes. So in this case, B and AB is going to be max of 1 comma 1, it's 1. ABA, LCS of ABA and A, BA is going to be 1 plus max of LCS of, I'm trying to fill this row, B comma AB. And we know that LCS of B comma AB is this. One row above and one row left. 1 plus this, that's 2. Alright? Awesome. Now, similarly, ABAN and BA. ABAN and BA. ABAN and BA. So, ABAN and BA would be what? What would it be here? What would be? You either, since n is not equal to A, it is the max of this and this, 1 and 2. It's 2. Now, here we have, since C is not equal to A, it's max of 1 and 2. You either pick this, you either don't pick this, or you don't pick. You don't pick C or you don't pick A. Max of 1 and 2 is basically 2. So, but since A, last year, A is equal to A, it's basically 1 plus 1. 1 plus 1 plus 1. It's basically 2. Okay, now is the case when your is else, like y underscore p asked the student y underscore p asked me what's going on in the else. Now we will see what's going on in the else. So 1. Now, okay, now what do we have? LCS of BAN comma AB. BAN comma AB. So what did we tell? We are either going to not pick the last one from BAN, which is basically LCS of max of LCS of BA comma AB, or because n is not equal to B, we are going to go into the else condition, right? Or LCS of BAN comma A. So we either pick, so we have multiple options. We either pick both. In this case, we cannot pick both because n is not equal to B. Now, we either pick exactly one of them, we either pick n, or we either pick B, or we pick none. Correct. So this is if we don't pick n. If we don't pick n, if we don't pick B. Now you might ask, where is the condition where we don't pick both of them? Yes, that's there here as well. If you go one step behind this is going to call LCS of BA comma A. This is going to also call LCS of, since n is not equal to A, we are going to call LCS of BA n comma empty string. So this is calling this and this is calling this. So we don't need to explicitly, if we write also, there's no problem, but we don't need to explicitly write this as, see in this case, this is calling this indirectly, it's basically not picking n and not picking B. So if we don't pick n and don't pick B, it's basically LCS of BA and A, right? BA and A. So it's already accounted for. We had 4 cases. We're either going to pick we're either going to pick both of them. When we have an option to pick both of them, we always pick it because it's better. And there's another option where you pick exactly one of them. You either don't pick the first one, or you don't pick the second one, or you don't pick both of them. All of them are covered here, isn't it? So similarly, we write this, since n is not equal to B, maximum of 1 comma 1, maximum of BA and AB. Wait, BA and BA and A. BA and BAAB, which is this, BA and AB, this is this, BAN and A, which is this, maximum of 1 comma 1, this is 1. Similarly, ABA and BN, A is not equal to n, so we write this as max of 2 comma 1, 2. N is equal to n, so we write 2 plus 1, 3. We'll just fill the table. C is not equal to n, maximum of 2 comma 3, 3. A is not equal to n, maximum of 2 comma 3, 3. D is not equal to B, maximum of 1 comma 1, 1. D is not equal to A, maximum of 1 comma 2, 2. D is not equal to n, maximum of 2 comma 3, 3. D is not equal to C, 3, 3 comma 3, 3. Alright, Is this clear so far what I'm doing? Are there any doubts here? Is there any part you want me to re-explain? I'll be happy to do so. Similarly, E is not equal to B, maximum of 1, comma 1. E is not equal to A, 2. E is not equal to N, 3. E is not equal to C, 3. 3. A, we have A here, maximum of 1, comma 1, because A is not equal to B, 1. But A is equal to A. So maximum of 2, maximum of, this is 1 plus 1, 2. Right. Now, A is not equal to N. So you just write that maximum of 2, comma 3, just 3. A is not equal to C, maximum of 3, comma 3, 3. But A is equal to A, maximum of 3 plus 1, 4. 4 is our answer. 4 is our answer. Right, 4 is our answer. Now, okay, we got the answer, but what is the longest subsequence? By looking at this table, how do I compute what the longest subsequence is? What is the longest subsequence? It's very simple. It's very simple once you compute the table. Very simple. So we start at the end. We start at the very end. 4. We start at the very end. Now, if the two characters are equal, we'll go one step up. One step up. Now, you can go at any direction now. All right. You can go at any direction. You can go at any direction. So now since the two characters are not equal, this 3, the number 3 is taken from max of 3, comma 3. So this 3 could have come from here and come from here. Turns out you can take from anywhere. So you can go here, you can go here. And this 3 can come from here or here. It can go up. You can choose one of them, any one of them. This 3 could have come from here or here, but it came from here, max of 2, comma 3, right? So it came from here. This is the path that we traversed. But since n is equal to n, there's a diagonal route being taken here. N is equal to n. N is equal to n. That means this 3 came from 1 plus 2. We mark the crucial cells here first. That's how we trace the path, and then we get the subsequence. We get the subsequence. We trace the path and then we get the subsequence. And then 2 came from, where did 2 come from? 2 came from this 1 plus 1. This came from this 1 plus 1 because A is equal to A. And this one, it came from, since B was equal to B, it came from this imaginary row where, wait one second, sorry, this one came from just B. So this is the last cell basically, right? So what did we do? Whenever we made a diagonal jump, we add the character that we made due to which we made the diagonal jump here. So we add the character A, and in the end here, we didn't make a diagonal jump, not a diagonal jump. But here we made a diagonal jump again. You have the character A. Sorry, here we made the diagonal jump because we had the character n. N was same as n. So we write n here. Now, and then we made another diagonal jump. We made the diagonal jump because of 2. The character A. We write another A here. And then we go here. 1. Why did 1 come? Because of the character B. That's it. That's our longest common subsequence. You can see that B, A, N, A is a subsequence of this. B, A, N, A is a subsequence of this. So it satisfies, right? Huh? Any doubts with this? Is there anything you'd like me to re-explain? Any doubts with the solution, first of all? I understand this might be a bit hard if you're doing it for the first time. Any doubts? Aniket, you understood. Great. I want you to understand this, so I want to be clear about it. So any doubts with the solution so far? Question 115 on lead code. One sec. I'd like to stick to my thing, but like you can post the link here and I can look at it later. Which part again? Last part. Okay. Upani wants me to explain the last part. Sure, I would love to explain the last part. So clearing everything again. All right. How did we get the longest common subsequence? So how are we going to do it is, we know that the answer is 4, right? We know that the answer is 4. Let me clear all this. One second. Let me clear all this. What if there are two common subsequences of same length? Omar, common subsequence is it's by definition like the subsequences are going to be of the same length because they're common. I'm not sure what you mean. Can you be more clear? All right. Now, how are we gonna get the actual path? So now we know 4. Now, where did 4 come from? 4 did not come from this. 4 came from dp of this comma this is equal to this plus 1, right? Because a was equal to n. A was equal to a, which means that what did we decide? That means a is going to be in our subsequence no matter what. So let's answer equals. A is going to be in the subsequence, and it's going to be the last character of a subsequence, right? All right. And now we have a smaller problem, which is this, right? Now let's see what's the longest common subsequence over here. 3. dp of this comma this came from the maximum of this and this. We can literally take any of them, right? So let's check this, like no option. There's no problem because we're neither picking C nor E, right? We're neither picking C nor E. So in this, so we're not adding anything to our subsequence. Now we have 3 again. It can either come from 2 or 3. But it can't come from 2 because we took maximum of 2, 3. This number 3, it came from here. And similarly, this number 3, it came from here. But this number 3, since n is equal to n, this character is equal to this character, it came from the diagonal. Maximum of, since we're picking both of them, now we have a really smaller problem. A, B, A and B, A. Since you're picking n always, we add an n here. I'll code it for you and you'll understand very clearly. Omar, can you be more clear about your question? Because I don't understand what you mean here. Like, what if there are two common subsequences of same length? That doesn't make any sense to me. Now, 2, we have 2 here. Now, again, we have the same situation where the characters are same. A is equal to A. 2 and then 1. So we have an A here, right? Now there is this one common subsequence of length 1, A, B and B. Since B is there's only a single character here, it has to be B. So we just write B here. That's a subsequence. Is this clear? Upmani, is this clear? I'll be more clearer when I write the code. Any doubts so far? Just getting some water. Any doubts so far? Upmani or Aniket, are there any doubts? Other people in the live chat as well? Is there anything you'd like to ask me? Awesome. That's great to hear. It's clear. Awesome. So I'll get to coding without any further wait. Awesome. Can you see the code? Can you all see the code? Can you all see the code? So Aniket is asking me, sometimes I don't understand when to take a 2D array and when to take a 1D array. So don't think about it in terms of 2D array and 1D array. Think about DP in terms of states. So in this, we saw the state was a two-dimensional thing where, like, you don't have to, like, row and column is enough to represent the state. Don't think about it in terms of array. How do you want to represent it? First, think about it in terms of states and how you reduce the subproblem. And then once you reduce it to the subproblem, try to represent the subproblem in terms of some finite numbers or discrete. Try to discretize the subproblem, like label it some. And now, depending on how you label it, storing it won't, like, if you're representing using two states, two like independent states, then you need a 2D array. Similarly, like, if you don't need two states, then you need a 1D array. If you just need one number to represent what your state is, you need a 1D array. Sometimes, yeah. Like, first try to understand what you want to represent from what you want your DP state to represent. Don't think about it in terms of like 2D array, 2D matrix. No. First think about it in terms of like, what does your subproblem represent, and how do you want to like represent it in terms of smaller subproblems, and then try to put a few numbers, like, how can I tag this subproblem? Like in this case, the subproblem can be tagged as the length of S and the length of T. That's being reduced every time. Got it? All right. So first of all, how does the input look? You're given a string, you're given strings S and T. Find one longest string. So you just need to take two strings first and then print the longest string. All right. Awesome. So first we take in two strings S, C, and S, T. All right. Now, how do we do it? First, let's compute the DP table. Vector int DP of S, comma. Since we know the answer, the size of this, m equals t dot size. Oh, Pan is saying, okay, Omar, you're saying that, okay, two common subsequences of same length, okay, then this solution would print either of them. Like, it would really print either of them. For example, since you have two choices, okay, that's a really good question, to be honest here. For example, all right, awesome. Good question, Omar. So sorry for not understanding the question. So basically, the doubt was, if there are two subsequences of A and the longest common subsequence of these two strings is like of length 3, BAN. It's also RAN. Now how would you what would you do then? Turns out you can print any one of them according to the solution. And you remember when I took the choice where, I'll take a smaller example where it's the last two characters aren't there at all. It's simply RA and AR. This is a simpler example, right? I'll do it for this. So Let's just compute the DP table here. R A A R. This is 0. R is equal to R, so it's equal to 1. Now here this answer A is equal to A, so it's equal to 1. Here RA, since R is not equal to A, we write maximum of this comma this. We take it as 1. So, but how do we retrieve the subsequence? How do we retrieve the subsequence? Okay, when we have 1, we decided that it's either coming from this or this. We took the choice of taking it from left hand side. If we take it from up, you'll get one sequence, one other subsequence. We take it from up, we go up here. Now so either this one came from either this or this, right? Fine. Option 1 is we take it from here. We get one subsequence. Now what does this represent? This came because of just A. Now if we go up, this came because of just R. In our solution, we're just taking left every time because, I mean, you can take anything, right? The answer is the length of the answer exactly. The length of the answer is going to remain the same. We just need to print any subsequence of the two strings. And what does that mean? We can choose our thing. So we just go left every time instead of when we have an option of going up and left, we go left because going left is also an option which will give us the optimal answer. By going up as well, we can get the optimal answer, but we choose to go left because, I mean, both are like equivalent, right? So why do we care? I hope that made the answer clear. If we choose to go left, we get A. If we choose to go up, we get R. Again, in your solution, if you want to go up, you can still go up in your solution. That will perfectly work as well. So you'll have several choices where you want to go up and left and so on, right? And I'm going to choose to go left every time, or I can choose to go up every time. Both will give me the correct answer. Or I can randomly choose to go left and right depending on some parameter that, randomly go up and left, and that will work too. Is that clear? Is that clear? Any doubts with the solution so far? Any doubts with the solution so far? Is there anything you'd want me to re-explain? Awesome. 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 All right. So I'll start off with coding the solution then. So first I declare everything with 0. Now for int I equals I'll just call it small n equals 0, n less than capital N, n plus plus. For int m equals 0, m less than m, m plus plus. Aniket, could you just like tell me the brief of the question here, because I think going there would be unfair to everyone else. So like going to lead code would be unfair to everyone else. I'd like to help you, but like if S of n equals S of m, else T of m dp of n m equals dp of n minus 1 m minus 1. But if n equals 0 or m equals 0, dp of n m equals 1. right? Else dpnm equals, as we discussed, 1 plus. Else if they're not equal, then dp of max of dp of n minus 1 comma m. First we initialize dp of n comma n 0. Now if n is greater than 0, otherwise you'll have dp of minus 1, which is anyway going to be 0. If m greater than 0, dp of nm equals max of dp of n. All right. Is this clear? Is this clear what I've done here? Is it clear what I've done here? Okay, Aniket is asking to count the number of distinct subsequences of S which is equal to T. I would like to explain this, but I don't have time to finish the syllabus over here, so I really like to explain that. But the basic idea for that question, so okay, first let me finish this question here. So first, is everything clear over here? So if the last characters of both strings are equal, if one of the indices are 0, then we just label them as 1, right? We just label them as 1, meaning there's only one character in one string and there are a bunch of characters in the other string, but the first character is same as the last character of the first string, and it's same as the last character of the other string. It means that you're going to pick the character. Why not? Because if you're getting 1, the solution, so you're picking it. And the other option is oh wait, indentation is screwed up. Okay. All right. So if otherwise, if what do you say? You don't pick, you choose to not pick the nth character. This is basically the previous rows right up. You're taking the maximum of the cell right up. This is you're taking the cell right left to it. Maximum of both the cells. In this case, 1 up and 1 left. You're taking the diagonally opposite thing. That's what we did in the solution, right? When you're drawing the table. All right. Is everything clear here? Any doubts so far? Any doubts so far? Oh, sure. Is this enough? All right. Now the answer is simply C out dp of the longest common subsequence is basically dp of n minus 1 comma n minus 1. Right. Awesome. Awesome. Any doubts so far? Is there anything you'd like me to re-explain? Here basically I declared the dp array of size and n cross m matrix, and then as we discussed, if n is equal to m, then we just go diagonally opposite ones. These are the boundary cases, don't worry about them. Now otherwise we take 1 plus diagonally adjacent. If otherwise, here it's when the last characters are not equal. That means we take the maximum of 1 above and 1 left, isn't it? Awesome. All right. Is there any doubts? Shall I go ahead and print the string? But if you have any doubts, please let me know in the live chat. I would love to re-explain it. Like if there's any part which is a bit confusing to you, I'd be happy to re-explain it. So how do you get the idea that it's a DP approach question? So okay, let me tell you, there are a bunch of standard DP questions that, you know, if you don't know already, it's good to know them. Like it's normal to not come up with a DP solution directly. It's because DP is sometimes hard, especially in this question, for example. Like if you haven't, so this was one of the questions where, yeah, like there are some questions that you learn DP with, and this is one of those questions, and it can be a case of like aha moment where, okay, how could you have come up with a solution? But sometimes knowing more DP problems helps with coming up with more DP problems, coming up with more solutions. Sometimes it's just a repeat of a, idea. We don't need to traverse till n less than equal to n and m less than equal to m, because no, in this case it's dp n minus 1 represents the longest. Okay, Aniket is asking why shouldn't we traverse till n equals capital N and capital M? Shouldn't we traverse till here? Like, shouldn't this be equal to? That's what Aniket is asking, if I'm understanding him correctly. No, because we just need to know what does the dp state represent? dp of n comma m represents, dp of I comma j represents 0 to I in S, in string S, and 0 to j in string T. What is the common subsequence in both of them? Both the prefixes. And what that might or might not include the last character. It can not include the last two characters as well. That's still fine, right? That's still fine, right? So Omar, what do you mean by breakdown steps? Can you please explain it to me? So here in this problem, first you need to understand that subsequence means, try to break it down. It means that, what is the subsequence here? Subsequence here means that you're either choosing the last characters of both strings, or you're not choosing the last characters of both strings, or you're choosing exactly one of them. Here, let me tell you that even if you write this n greater than 0 and m greater than 0, this will give you the same answer, because this will give you the same answer. I'm not writing this. So this is where you choose. I'll tell you what's happening. Here, choose last. So even if you remove this also, it will work. I'll tell you why. So here, we are not choosing last character from S. We are also not guaranteeing to choose the last character from T. We're just saying we are not choosing the last character from S. This will further, the smaller problem will further take care of the part where I can either choose T, the last character from T, or not. That's going to take care of it later. Similarly, there are overlapping subproblems here, by the way. So we don't choose the last character from T. Here again, we are not saying that we're going to choose the last character from S, because we might or might not. That would be taken care of later. Here we don't choose from both. I'll tell you why this is redundant. We don't need to write this. Even if you write this, the answer is going to be correct, but we don't need to write this. Why? Because dp n m is equal to max of dp n minus 1 comma m comma dp of n comma m, like n minus 1 m, and n minus 1 m is already, it will already call n minus 1 and m minus 1, right? When it calls n minus 1 m minus 1, it already means that you're not choosing T. But it might not call that as well. It will choose the best case scenario in that. Like if you don't choose the last character from S, what is the best case scenario? If we don't choose the last character from T, what's the best case scenario? We might or might not choose the last character from S. If we choose, well and good. If we don't, that's still fine. You couldn't have taken it either way. This is clear. So basically a subsequence means you either include a character or you don't include a character. That's what it means, right? And that's where the DP comes from. So we need to pick some character to include or not. So we pick the last character. So we either include both characters or exclude both characters or exclude one character or exclude no character. Like basically it's exclude no character, exclude both characters, or exclude no character at all. So in excluding at least one character, you're already accounting for excluding both characters, because this problem will already solve for what if we exclude both characters as well. So here identifying the DP state was about finding what the smallest subproblem was. The smallest subproblem was iterating on the prefix lengths. Like the first, you either take the last character or you don't take the last character. So now you have a smaller subproblem now if you don't take the last character, right? Now DP expression is basically, now how will you represent the smaller states in terms of how will you represent the bigger state in terms of the smaller states? That's a DP expression. That's solely the DP expression. Now base condition is, base condition is something that you can work it out. Base condition is basically the boundary cases where you know, if there's no smaller state defined, you can't define a smaller state. For example, in this case, this is the base condition. You can't write dp -1 because we never defined it, and it's gonna go out of bounds if we call this here. So that's when you need to introduce a base case. All right, Harshit, the session is almost complete. Yes, I am going to solve another question. Yes, the longest path in a graph. That's going to come up in the next video. All right. Awesome. I hope that's clear, Umar. But otherwise, like, there's no shortcut to finding a DP solution. You just need to practice more, and you need to be aware of the standard problems, without which it can get hard. So let me just print the string quickly. So what did we do here? We iterated from the bottommost, right? See, I'll print the string quickly. While Manish, I don't have an SD sheet. If S of Cn equals T of Cn, here I'm computing what the longest common subsequence would be. String answer. It's initially null. If S of Cn equals, then you directly do, what do you say? What do you do here? Then Cn minus Cm minus. Else, what do you do here? If dp of Cn Cm equals dp of Cn, I'll actually, I'll struck the C underscore. It's becoming an annoyance. All right. Again, just made an error here. All right. Now, while the pointers are greater than or equal to 0, Suraj, SD sheet. I don't know. I'm not aware of the concept of an SD sheet, to be honest. Yeah. If dp of n-1 nm equals dp n-1 comma m, then we do n minus minus. Else it has to be m minus minus. But here there's this condition where n is greater than 0, and yeah. We don't need to write this condition. It will always go into one of these two conditions, right? I'm just writing this for the sake of convenience. All right. Awesome. Here, when this happens, every time that this happens, we write answer. Remember, answer plus equals SFN. But note that we are adding the answer. We are adding the last character to the start instead of the end. So we just need to print the reverse of the answer. See our answer. All right. Okay, what are we doing here? I understand that this code might be a bit tricky to understand. Else it'll never go in here. I just wrote that so that you can understand it correctly. I just wrote this part. You can just write an else here, but ideally it should never go here. All right. Okay. Now what are we doing here? If Sn is if the characters are equal, then answer plus equals Sn or Tm, anything. Now this is when you're going through the diagonal. Here, we're going one cell up. We're going one cell left. All right. Wherever there was an equality, we just move in that direction, right? That's what we did. And whenever you're going diagonally up, we print the answer, like we added to our solution. This is simple. Any doubts? Any doubts with the solution, anyone? Any doubts with the solution? This is clear. Do you want me to re-explain some part over here? Awesome. Suraj, you can do, but it'll be quadratic. I mean, the DP is you can do SFN, answer is equal to SFN plus answer. But as I said, it'll be quadratic. I mean, it won't change the overall complexity because the DP is already quadratic n into m, so it won't change the complexity per se. But I mean, try to it won't change the complexity. But I mean, if there's a chance to optimize somewhere, then why not? Like answer is equal to SFN plus answer. That is the that would be a bit slow. Again, it wouldn't matter because you're doing the n in time anyway. Yeah. All right then. All right then. We can end the class today. We can end this session. There's another session coming up, so please come there. Like that's going to be a little more tricky. The problem's going to be a bit more tricky. It's about finding the longest path in a directed acyclic graph. And if you don't know a lot about graphs, if you don't know what Dijkstra is, if you don't know what shortest path is, that's perfectly fine. I'm just going to show you a DP approach, and I'm going to show it to you in a very simple fashion. All right. That's also an Atcoder DP problem. I'm going to show it to you in a very simple fashion. Like it's not going to be a very hard problem either. So what you need to get with yourself is very basic representation of graphs, but I will again revise that for you again. So there's no issue with that. Awesome, then we can end the session today. Please do come to my next session, which is gonna happen in like about 5 minutes, actually 3 to 4 minutes to be honest. So, and also do follow the Telegram channel for live updates on classes, so you don't want to miss them. And if you think you did like this class, if you found it useful, please drop a like so I know it is useful. If you didn't find it useful, please let me know in the comments or in the live chat why it wasn't useful, so that I can incorporate it in my later classes. And if you think the content is going to be useful to you in your later classes, do subscribe subscribe so that you don't miss out on any content. And yes, so awesome. So please don't forget to attend my next class. See you. LinkedIn, I don't like sharing my LinkedIn, but you can just Google my name, LinkedIn my name, and you'll find it there. But I'm not active there, so yeah, there's that. Awesome, then I shall end my class today. I end my class now. Don't forget to